For decades, scientists believed they were on the right track with our understanding of the universe, but how do we deal with discoveries that initially seem impossible? Structures so unusual that they contradict conventional cosmology have often prompted discussions about the impact of discoveries like those made by the James Webb Space Telescope, JWST. Some claim that Webb has overturned everything we thought we knew about the universe and the Big Bang, but the truth is much more nuanced, and therefore much more exciting. Max Planck once said, "If you change the way you look at things, the things you look at change." Whether the German physicist had a view of things in mind that was specifically designed for infrared astronomy is uncertain. What is certain, however, is that the JWST has fundamentally changed our view of the universe. In theory, the $10 billion device could detect the heat of a bumblebee on the surface of the Moon from Earth. In practice, Webb has already identified a number of mysterious structures in the vastness of space that simply don't fit with our time-honored cosmological models. But how do you deal with discoveries that simply don't make sense on paper? Discoveries that have the potential to shake cosmology to its foundations. These are questions that experts had to grapple with after Webb's near-infrared camera, NIRCam, took a close look at a section of the sky near the Big Dipper. Experts discovered 6 reddish points of light in the images, which turned out to be a mystery. Based on the redshift, scientists from Swinburne University of Technology in Melbourne determined that the light took more than 13 billion years to reach Earth. It therefore originated from objects that existed 500 to 700 million years after the Big Bang. Furthermore, the characteristics of these points of light suggested that these were early galaxies that should not exist in this form at all. Researchers would have expected only tiny baby galaxies in this early period of the cosmos. No wonder, after all, according to our current knowledge, there was not enough normal matter back then to form galaxies the size of our Milky Way today. At least, that's the theory. But reality paints a different picture. In fact, all 6 early galaxies contain more than 10 billion solar masses of stars, and one of them could even have a stellar mass of more than 100 billion solar masses. To explain the presence of such massive structures at this early time, either the matter density in the young universe must have been 2 to 5 times greater than cosmological models predict, or the galaxies must have been born in a way that is completely unknown to us. Given this, researchers unsurprisingly describe the discovery as a real problem for science, a problem that should only deepen with future discoveries. The question arises: has Webb blown up cosmology? After astronomers tracked down the astonishing mass of these galaxies, they initially thought they had made a mistake. However, this suspicion was not confirmed in subsequent analyses. On the contrary, another galaxy, added to star maps a few weeks ago, underlines the fact that researchers should be prepared for further impossible discoveries in the future. Christened with the scientific name JADES, GS, Z14:0, this group of stars existed 290 million years after the birth of the cosmos. The structure not only became the oldest known galaxy but also another mystery. Although this galaxy existed at a time when, according to our understanding, the first stars had only just formed, it is already incomparably luminous. Analyses have shown that this galactic object already comprised several hundred million solar masses of stars. This raises the question: how was this possible? How could such a massive galaxy form in just 290 million years? Researchers assume that the collection of stars took around 100 million years to grow to its observed dimensions. The emission lines of oxygen detected in the spectrum indicate that several very massive generations of stars had already gone through their life cycles before astronomers observed this galaxy. But what do these puzzling discoveries mean for the big picture? If we have already been wrong about the structure formation processes in the universe, could we also have been wrong about the formation of the cosmos itself? The scientific consensus is that the universe was born in the Big Bang. Around 13.8 billion years ago, space, time, and matter emerged from an original singularity. Over time, the Big Bang theory has withstood a series of observational tests, explaining many cosmological characteristics. These include the redshift of light from distant galaxies, the presence of cosmic microwave background radiation, the abundance of light elements, and the evolution of galaxies and larger structures. Although the Big Bang Theory cannot say with absolute certainty which galaxies will develop where, it can indicate probabilities. Until the launch of the JWST, we had no direct observational access to the earliest stages of galactic evolution. But now, with Webb's observations, we are smarter. The galaxies discovered by Webb seem to challenge our understanding of the Big Bang and galaxy evolution in the early universe. Advocates of the Big Bang Theory emphasize that the situation is not as clear-cut as it seems. The headlines proclaiming the end of the Big Bang ignore a crucial detail. Astronomers estimate the redshift, which gives the distance and therefore the age of galaxies, using a technique called photometry, which is incredibly uncertain. Before conventional cosmology is completely broken, more precise measurements of redshifts and the ages derived from them would be needed. This is why many Webb discoveries have subsequently turned out to be less spectacular than initially thought. For example, the unusually massive galaxies detected in 2022, thought to have existed 200 to 250 million years after the Big Bang, turned out to be much less remarkable upon closer inspection. A few months and a series of more precise measurements later, the record-breaking structures were found to be completely normal galaxies. The redshift of one structure was corrected downwards to 4.9, meaning that the galaxy's age increased from 240 million years to well over a billion years. This provides more than enough time to explain their size and shape using the standard Big Bang theory. But what about the other discoveries? Did the new galactic record holder, JWST Z14:0, actually form significantly later than the first dataset suggest? Not really. The corresponding redshift of 1432 should actually be confirmed this time. Does this mean that the Big Bang Theory has had its day after all? Well, that depends on which expert you ask. Some researchers believe that the Big Bang was actually a big bounce. According to this model, the universe is subject to an eternal cycle of decline and rebirth. Some experts have problems with the concept of a single universe, suggesting instead that the cosmos has been eternally expanding in an inflationary manner since its birth. This process would only come to a standstill within bubble-shaped subareas, in which a multitude of sub-universes form. Each cosmic world could contain completely different values of the natural constants and thus different physical laws. However, if Nikodem Poplawski has his way, we are all inside a black hole. The researcher from the University of New Haven is convinced that a kind of primordial seed once ripened in the heart of one of these massive objects, ultimately bursting open and paving the way for the unfolding of our cosmos. Conversely, black holes would embody natural gates that connect two universes, but with the restriction that the cosmic gate can only be passed through from one side. Despite these varied theories, the majority of astronomers continue to adhere to the established ideas. It's quite possible that the existence of galaxies such as JWST Z14:0 can be explained within the framework of the Big Bang Theory without requiring far-reaching changes. For instance, large black holes could have formed before these galaxies and triggered bright bursts of star formation with their gravitational force. Alternatively, supernova feedback and other mechanisms may have fueled the unexpectedly high star production of early galaxies. But regardless of whether it was the Big Bang, the Big Bounce, or the multiverse, none of these models are able to answer the questions of before and why. What caused something to emerge from nothing 13.8 billion years ago? Was there a trigger, or was it mere coincidence? Stephen Hawking once said that time itself only began with the Big Bang, which is why dealing with the before makes no sense at all. The Big Bang embodies an event that could not have been caused by anything or anyone. The laws of nature themselves would show us that the cosmos could have come into being without the need for energy or a cause. Other experts question this, and who knows, perhaps the key to knowledge is just one new James Webb discovery away. In any case, the quest for understanding the universe continues, with the potential for even more groundbreaking revelations. The ongoing discoveries made by the James Webb Space Telescope, JWST, continue to challenge our understanding of the cosmos in ways we never anticipated. Consider the galaxies discovered that seem to defy the timeline of the Big Bang, forming and growing far earlier than our models would suggest. These observations force scientists to rethink the very foundations of cosmology. Some experts speculate that these findings might necessitate new physics or revised theories about the universe's early stages. The sheer mass and luminosity of these early galaxies raise profound questions. How could they have formed so quickly after the Big Bang? Were the conditions in the early universe different from what we've always believed? And if so, what does that mean for our understanding of cosmic history? As astronomers delve deeper into these mysteries, they must grapple with the possibility that our current models are incomplete or even flawed. Yet, the scientific community is divided. While some argue that these findings could be integrated into existing frameworks with minor adjustments, others believe that they point to more radical changes. The idea of a big bounce, a universe that eternally contracts and expands, has gained traction, as has the possibility that we live in a multiverse where each universe has its own unique physical laws. These theories challenge the conventional notion of a single linear Big Bang, suggesting instead a more complex, dynamic cosmos. However, the JWST's discoveries also remind us of the need for caution. Early interpretations of data can be misleading, and only through rigorous analysis can we determine whether these findings truly herald a new era in cosmology or simply refine our existing models. The implications of the James Webb Space Telescope's discoveries are far-reaching, potentially revolutionizing our understanding of the universe's formation and evolution. For decades, the Big Bang theory has been the cornerstone of cosmology, providing a framework to explain everything from the cosmic microwave background radiation to the abundance of light elements in the universe. However, the unexpected detection of massive, mature galaxies at a time when the universe was thought to be in its infancy challenges this framework. These galaxies, formed only a few 100 million years after the Big Bang, seem to defy the conventional timeline, suggesting that the processes that govern galaxy formation are far more complex than previously thought. The sheer scale and mass of these early structures imply either an unprecedented density of matter in the early universe or unknown mechanisms of rapid star formation. This has led some scientists to propose alternative models, such as the Big Bounce or multiverse theories, which offer different explanations for the universe's origin and development. The Big Bounce posits an eternal cycle of contraction and expansion, where the universe repeatedly collapses and then bursts forth in a new Big Bang. In contrast, the multiverse theory suggests that our universe is just one of many, each with its own set of physical laws and constants. These ideas, while intriguing, remain speculative and require further evidence. Yet, they highlight the importance of the JWST's role in expanding our cosmic horizons. As more data is collected and analyzed, the scientific community will continue to debate and refine these theories, seeking to unravel the mysteries of the universe's earliest moments. In the end, whether we revise our current models or embrace entirely new ones, the journey of discovery is what drives science forward, constantly pushing the boundaries of what we know. Remember, the journey to understanding the universe never ends. Keep exploring, keep questioning, and we'll see you in the next video.